Hello everybody and welcome to the video for topic number 2. In this one we'll take you through some problem solving techniques. Here are our objectives for today. We're going to go through and show you how to write algebraic expressions that could be simplified, and we're going to apply steps for problem solving. Here are some general strategies that we're going to do as we go through and do these problem solvings. First thing we're going to do is just try to understand the problems. We're going to read the problem and reread it again as we need to. We're going to propose a strategy. We're going to take advantage and draw pictures at times if we need it. And we're going to choose a variable to represent the unknown. For the most part today, we're going to choose x as our unknown. We're going to translate the problem and put them into an equation. Once we have that, we'll solve the equation and interpret the results. And we're also going to make sure we answer the problem that's been given to us. Let's go ahead and begin here with our first problem. Here we want to write the following algebraic expressions and simplify if we need to. And we've got two different problems. Let's start with letter A. We want the sum of 3 consecutive integers if x is the first consecutive integer. So the first idea here is understanding what is a consecutive integer. A consecutive integer is numbers that are written right after each other. So for example, 1, 2, and 3 would be a set of 3 consecutive integers because they're written one right after another. So we need 3 integers that are written one right after another, and the only thing they tell us is that the first integer is x, basically saying it's unknown at this point. So let's pretend like x in this case was 1. The next number that would come after 1 is 2. And in order to get to 2, we would have to take the first digit and we would add another 1. So for our second one, we'll just take x and we'll add 1 to it. For our third digit, we would want it to be 3. Well, again, if x is our first digit and it was 1, in order to get from 1 to 3, I would have to add 2. So to get our third digit, I would have to take x and add 2 to it. That would give me the first 3 consecutive integers. They want the sum of these. So in order to find that, we're just going to take each of these 3 parts and add them together. We'll do this by combining like terms. So I take a look here. I see I've got x, x, and x, and all of them are being added. X plus x plus x will give me 3x. And then I've got a positive 1 and a positive 2. 1 plus 2 will give me 3. I can't combine 3x and 3, so this is my final answer. This would be the sum of the 3 consecutive integers, assuming x was the first integer. For the second problem, we want the perimeter of the triangle given these 3 sides. One of the sides is x, one is 5x, the other one is 6x minus 3. We remember simply that perimeter is the distance around. So essentially, they would want us to add up all the sides. Now, if we had numbers, we would add up all the numbers and get the perimeter, but in this case, we just have expressions. So we're going to kind of do like we did on the last problem, and we're just going to add up all the sides. Side 1 is x, side 2 is 5x, and side 3 is 6x minus 3. We'll go through and identify like terms, and the like terms we have in this case are x plus 5x plus 6x. The minus 3 doesn't have anything to combine with, so we'll just drop it down at the end. This is x, so we'll pretend if we need to. We can write a 1x here to remember that this is really 1x. But now I've got 1x plus 5x plus 6x, which gives me 12x. The negative 3 doesn't combine, so we'll drop it down. And this is the algebraic expression, 12x minus 3. This represents the perimeter of this triangle here. Problem 2. The 3 busiest airports by number of passengers in the United States are Atlanta, Chicago, and Los Angeles. Chicago's O'Hare Airport had 3.1 million more passengers than Los Angeles International Airport. Atlanta's Hartsfield-Jackson had double the number of passengers Los Angeles International Airport, less 31.9 million. Write the sum of the passengers from these 3 airports as a simplified algebraic expression. Let x be the number of passengers at Los Angeles Airport. So again, when we look at this, we're dealing with 3 airports. We've got LA, we've got Chicago, and we've got Atlanta. Now it tells us down here at the problem, we want X to be the number of passengers at Los Angeles International Airport. So we're going to identify Los Angeles as X. We don't know what X is, but we know it is some amount. Then we're going to use some of the clues that they had at the beginning. They said Chicago O'Hare's Airport had 3.1 million more passengers than Los Angeles International Airport. Again, we don't know how many LA had, we just know that they had X, and we know that Chicago is 3.1 million more than whatever LA was supposed to be. So for Chicago, we would take whatever LA's was, and we would add 3.1 million to it. Now, we don't need to write the million here, we'll just write it as 3.1 to represent it. We're going to do the same for Atlanta. It tells us here Atlanta's Hartsfield-Jackson had double the number of passengers as Los Angeles International Airport, less 31.9 million. So the has 2 kind of clues here for us. It says Atlanta's airport was double the number of passengers at Los Angeles. Again, remembering Los Angeles in this case is X. So if I know that this is X and I need to double it, Atlanta is just 2 times that. But it also says it's 31.9 million less than whatever it is doubled. Less in this case means subtraction, so we'll need to subtract 31.9 million to find Atlanta. And these are the 3 algebraic expressions that will represent each city. They want the sum of these. So we're going to take each of these and we're going to add them together. So I'll take LA plus Chicago plus Atlanta. And just like we've done before, we're going to go through and combine like terms. I've got X plus 2X here that I can combine. And also in this case, I can combine 3.1 and negative 31.9 because they're both whole numbers without a variable. X plus 2X gives me 4X, remembering that these are both 1X's. 3.1 minus 31.9, because that's a minus sign, gives me negative 28.8. 4X and 28.8 don't combine, so that is the algebraic expression that represents our answer here. Here again, we're trying to find 3 numbers such that the second number is 3 more than twice the first number, and the third number is 4 times the first number. And the only other thing it tells us is that the sum of all 3 numbers combined is 164. So we're trying to find 3 numbers. We'll call it the first number, the second number, and let's call it the third number. Let's go through some clues that they give us. They tell us that the second number is 3 more than twice the first number. The problem is we don't know what the first number is. So if we don't know what something is called in math, we give it a variable name. So let's call the first number X. It tells us the second number is 3 more than twice the first number. Well, if the first number is X, then twice the first number is 2X. And 3 more to that means we've got to add 3 to it. It also tells us down here that the third number is 4 times the first number. Again, we don't know what the first number is, we just know it is X. So that means that the third number, if it's 4 times it, is just simply 4X. The last clue that it gives us is that the sum of the 3 numbers is 164. So that means I should be able to take the first number plus the second number plus the third number, and it will equal 164. And now we have algebraic expressions that represent all of these. The first number is represented as X, the second number is represented as 2X plus 3, and the third number is represented as 4X. So that means all of that combined is equal to 164. Let's combine like terms on the left side. We've got X plus 2X plus 4X. We're not going to combine the 3 and the 164 because they're on opposite sides of the equation. X plus 2X is 3X, and then add the 4X, I get 7X here. The 3 comes down, and it's equal to 164. My job is to get X by itself. I have to get the 7X by itself, so I'm going to move the positive 3. And in order to do that, I need to subtract it from both sides. On the left side, I'm just left with 7x, and on the right side, I have 161. Dividing both sides by 7, I find out that x is equal to 23. Now go back and make sure we answer the question. The question asked us to find the three numbers, so it wants us to identify it. So what we're going to do now is go back to our original problems, and we're going to plug in 23 everywhere it goes. So for the first one, because x was whatever the answer was for the first one, the first number was 23. For the second number, we'll just take 2 times 23, and we'll add 3 to it. 2 times 23 is 46, and 46 plus 3, the second number was 49. And for the last number, we'll simply take 4 times 23, the number that we found. And in this case, 4 times 23 is 92. So the three numbers we needed were 23, 49, and 92. Problem number 4. This one involves a little bit of discounts. Suppose that a computer store just announced an 8% decrease in the price of a particular computer model. If this computer model sells for $2,162 after the decrease, find the original price of the computer. So, in this case, we need to identify what x is, and our unknown here is, well, what is the original price? What is the original price? Okay. One thing we do know is that we took the original price and there was an 8% decrease, which means it got smaller. We subtracted it. So if the original price was x, we'll decrease it by 8%, and we'll write 8% as a decimal, so we'll call it 0.8. So we're going to take the original price, and we're going to decrease 8% of the original price, and after that happens, it's going to equal $2,162. Now we can go through and solve this for x. These are like terms because they're on the same side. So we'll go ahead and combine them, remembering that this is just 1 here. 1 minus 0.08 gives me 0.92x equals 2,162. My job is to get x by itself, so I will divide both sides by 0.92. Now don't be surprised when you divide by a number that's smaller than 1, just like 0.92 is, the number is going to get bigger. So when we do that in our calculator, we actually get $2,350. So the original price was $2,350, and after an 8% discount, it became $2,162. Finding the lengths of triangle sides. A pennant in the shape of isosceles triangles is to be constructed for the Slidell High School Athletic Club and sold at a fundraiser. The company manufacturing the pennant charges according to the perimeter, and the athletic club has determined that the perimeter of 149 centimeters should make a nice profit. If each equal side of the triangle is twice the length of the third side, increased by 12 centimeters, find the lengths of the sides of the triangular pennant. So a couple things here. We know that it is an isosceles triangle, and if you don't remember what an isosceles triangle is, that is a triangle that has two sides that are the same. So we'll make a mark here to show that those two sides are going to be the same equal amount. We know that the total perimeter of all of this has to be 149. The only other part we know is that each equal side of the triangle is twice the length of the third side, increased by 12 centimeters. Do we know what the third side is? We do not. So we're going to call that x, because anything that's unknown, we call x. Each of the equal sides is twice the length of the third side, increased by 12. If we increase something, we're adding. So each of the sides, if the third side is x, we know that each of the sides that are equal are twice x, increased by 12. And we can write that for both sides because they're equal. Now we know all the sides of the triangle, and we know that the perimeter adds up to 149. So we can go through and say that adding up each of these sides of this triangle will equal 149. Now let's combine like terms and solve for x. Here I've got 2x, 2x, and 1x that'll combine. And then I've also got 12 and 12 that'll combine. 2x plus 2x is 4x, plus x gives me 5x. 12 plus 12 gives me 24. And it's still equal to 149. My job is to get x by itself, so I need to move to 24. It's a positive 24. So I'm going to subtract 24 from both sides. The 5x will come down. 149 minus 24 is 125. I need to divide both sides by 5 to get x by itself. And in this case, we get x to equal 25. Now remember, that's not the answer because they want us to find the lengths. That's ultimately what we need to do. So we're going to go back in to each parts of these triangles, and we're going to plug in 25. We know that the third side is 25 because it was just x. And for this one, we'll do 2 times 25 plus 12. 2 times 25 is 50, plus 12 equals 62. Now we can also do the same for the third side, but we remember these two sides are equal. So if that side is 62, then this side also has to be 62. So our answer, our three sides, came out to be 25, 62, and 62. Our last problem, we're going to find 3 consecutive odd integers whose sum is 81. So we have a couple different things here that we're looking at. We're looking at 3 consecutive odd integers. Consecutive, again, meaning they're right next to each other. Odd, meaning that they're not divisible by 2. So for example, if I were to come up with 3 that would be consecutive odd integers, we could think 3, 5, and 7. These would be an example of 3 consecutive odd integers. Now, they don't equal 81, so they're not the correct answer, but it can at least give us the idea of what we're going to do to try and solve it. We're going to do it very similar to the first one we did, but instead we just have to remember that each integer is odd, so we're not going to the next integer. The first integer we don't know, we'll call it x. We're going to work everything off the first integer being x. And let's pretend that first integer was supposed to be 3. Well, if it was 3, the next one we found should have been 5, because that's the next odd integer that's next to 3. Well, if x is 3 and I want to get to 5, then I would need to take x and I would need to add 2 to it. Because if x was 3, 3 plus 2 would give me 5. So that's what we're going to use to represent the second integer. If the first integer is 3, then the third integer has to be 7. Well, how did we get from 3 to 7? We would have to go through and add 4, which is what we're going to do here. If the first integer is x, in order to get to the third integer, I would have to add 4 with it. And this would be the first 3 consecutive odd integers. It also would be the first 3 consecutive even integers if we wanted to do it as well, because even integers, 2, 4, and 6, are also 2 apart from each other. So we can kind of use this diagram over here for any even or odd integers. Now it tells us the sum of all 3 of these is equal to 81. So I'm going to take all of these integers and I'm going to add them up and I'm going to set them equal to 81. Once again, I'll combine like terms. I've got x's here that'll combine. I also have positive 2, positive 4 that'll combine. X plus x gives me 3x. 2 plus 4 gives me 6. And I know that's equal to 81. Solving for x, I need to minus 6 from both sides. I have 3x equals 75. I'll divide all the sides by 3. And I'll have x equals 25. Now go back and understand. What does x equal 25 represent? That represents the first of the 3 consecutive odd integers. Meaning, if I want to get all 3 of them, I would need to take each of these problems and add 25 to them. So the second one is just 25 plus 2, which is 27. And the last one is 25 plus 4, which is 29. So the three consecutive integers who sum to 81 are 25, 27, and 29. I hope working these problems can give you a better idea of how to problem solve for word problems. Draw out a diagram, and it should be able to help you be able to solve them.